here. Okay, so we are recording, got the mic going. Okay, so guys, again, don't be sad, but this is the last chapter of the semester. So we got chapter 7. It's only 4 sections, y'all. It's 7.1, 7.2, 7.3, and 7.4. So we're going to do, again, one section a day, okay? Okay, so guys, 7.1 talks about these things called terminating decimals. Terminating just means that the decimals end, okay? And it says, you know, in most school programs, y'all, fractions are introduced before decimals. Children will see 2 and 4/10 before they see 2.4, even though they represent the same number, okay? So let's see, we're going to talk about decimals and how do we write decimals and what are those place values for, okay? So again, this is all stuff that you'll be explaining this to your students, right? Whenever you're teaching, whatever it happens to be, right? First grade or third grade or sixth grade or whatever it happens to be, all right? So y'all, when we're using decimals, we're talking about fractions with denominators of 10 or 100 or 1,000, but the denominators are really powers of 10, okay? And so we start talking about place values, okay? So if you think about this, y'all, I have a couple of tables here, and they're just talking about place values. So if I was looking at this number right here, 128, and then it says and 95. Okay, the way I would read that, or the way I would write it as like a numeric or a number would be 128 and 95, right? And you say 95 what? You're always going to look at the last place value, okay? And whatever that place value is, so the way I would read this, I would say 128 and the decimal is always going to be the word and 95 hundredths, okay? That's kind of how I read that number. A lot of times, you know, just in general, we might say something like, hey, like this summer was really hot, right? And if you live on your own or you help with bills or whatever, and they might say, okay, look, the electric bill was really, really expensive. It was $372.95. We really don't, in terms of math, we really are not supposed to use the word and until we get to the decimal. Now, on everyday kind of language, right, we say $350, right? But it really is supposed to be $350. The and really is supposed to represent the decimal, okay? So again, like I said, when you talk to your friends, like, oh, you know, hey, I sold my car, I got $4,265, right? We just say stuff like that, but the and really is supposed to represent the decimal, okay? So let's see. It says terminating decimals can be written in an expanded form using place value and negative exponents. So for example, look at the number that I have right here, 12.61843. Okay, so the 1 is in the tens position. That's why it's 10 to the first. The 2 is in the ones position. That's why it's 10 to the 0. The 6 is in the tens position. Okay, the tens position, y'all, is 10 to the power negative 1. Okay, the 1 is in the hundreds position. Hundreds is 10 to the power negative 2. And we kind of keep playing that little game all the way down the list, okay? So for the first problem that I have here, y'all, it says write each of the following as a sum in expanded place value form, okay? So the way I would approach a problem like this, or I would show my students, is I'd say, look at the number we have. We have 0.924. Okay, so the first thing I'm going to do is I'm going to write a 9. Why? Because that's the first number. I mean, the number in front of it is a 0, so I'm not going to worry about the 0. But the first non-zero number I have is a 9. Okay, that 9 is in the tens position. So tens position, y'all, means 10 to the negative 1. Okay, plus the 2. The 2 is in the hundreds position. So in the hundreds position, that is 10 to the power negative. Okay, and then the 4 is in the thousands position, and that's 10 to the power negative 3. Okay. One way you can explain this to your students, right? Again, so you might be dealing with, like, say, a 4th grade class or something. And you might say, look, from the decimal point, how many spaces is the 9 to the right of the decimal point? And they would say, you know, miss or sir, it's 1 decimal point to the left. So look, if it's 1 decimal point away, I'm going to use a negative 1. If it's 1 to the right, okay? Look at the 2. The 2 is 2 decimal places to the right of the decimal place, right? And you can kind of explain this to students because students, especially at the elementary school level, y'all, understand patterns, right? They understand patterns. So when we understand patterns, it makes it easier for us to kind of figure out what's happening, okay? Now, let me do part B, and I'm going to use the same sort of approach. So look, y'all, 4 is in the hundreds position. Now, the hundreds position is always going to be a power of 2, okay? Now, we have a 0 there, so I'm not going to write the 0, but then we have a 3. The 3 is in the ones position. The ones is always going to be a 10 to the 0, okay? Plus, now I'm going to play the same game. Look, I have another 0, so I'm not going to worry about that, but I am going to use the 6. Now, since the 6 is 2 spaces to the right of my decimal point, that's going to be a -2. Yeah, because they're very good. So y'all, the question is, what about the 3? Anytime we're in the ones position, the ones position is always 10 to the power 0. Yeah, excellent. Good observation there, y'all. So the ones is always 10 to the power 0. The tens position, y'all, is always 10 to the power 1. The hundreds is going to be 10 to the power 2, so on and so forth, okay? So look, let's take a look at part C here. We have the number 536, and then we have some decimals after that. So again, the 5 is in the hundreds position. Remember, hundreds position is to the 2. The 3 is in the tens position, so that's 10 to the power 1. The 6 is in the ones position, so that's 10 to the power 0, okay? Plus, now I'm going to start doing the same thing. I'm looking at the numbers, the non-zero numbers, y'all. So when I'm going to zoom in just a tiny bit right here, okay? I'm looking at the non-zero numbers. So I'm looking at the 3 and I'm looking at the 5. When I look at the 3, since I'm 2 spaces to the right, it's going to be a -2. And then when I look at the 5, because I'm 4 spaces to the right of that decimal point, it's going to be a -4, right? And again, y'all, with students in, you know, I don't think you would necessarily do this in first or second grade. I don't even know about third grade, maybe in third grade, but definitely, you know, fourth grade, fifth grade type stuff. But when you start doing this, patterns is a really big part on how we learn things. And so, you know, I'm 49 now, so I'm older. And if you ask me, you know, do I remember everything about my elementary school days? No, I definitely remember like the fun days, the field trips and the little trips we take down to the park and all that kind of stuff. But regardless of, you know, do I still remember some of the things that they taught me in elementary school? Maybe not everything, but the way most of us learned is by patterns, okay? So let's look at part D, okay? I'm gonna go through part D, y'all. I'm gonna do the same process, okay? So if you notice, I don't have any non-zero numbers to the left of my decimal place, but we do have some to the right of the decimal place. Okay, so we have a 3. Anybody know how many spaces from the decimal point that 3 is? So here's my decimal point. All I'm going to do is count 1, 2, 3, 4, right? So that's 10 to the -4. And then 5 times 10 to the -5. And then 6 times 10 to the -6. I'm going to put a little dot here, y'all, just to be consistent. Oops, come on, pen. There we go. Okay. And that's really all I'm doing here, okay? So let me go ahead and start coming back over here, and we're going to do the same thing, y'all, except now we're going backwards, okay? So 10 to the third. If I think of 10 to the third, y'all, sorry, I'm trying to get my pen going here. If I think of 10 to the third, 10 to the third is 1,000, okay? So this is going to be 6,000, okay? 10 squared is 100. So that's telling me in the hundreds position, I have a 9, okay? 7 times 10 is 70. That's my tens position, okay? Plus 4, that's my ones position, okay? Now, I'm going to put my decimal point, okay? Look, That's one space to the right of my decimal point. So that's a 5 right there. That's two spaces to the right of my decimal point. That's a 3 right there. And all I'm doing is I'm just writing out my number the way it should be, right, in regards to where my decimal point is going to be. Okay. So look, I'm going to come back. I'm going to do part B, and I'm going to do the same kind of idea. Look, y'all, if 10 to the third was 1,000, 10 to the fourth is going to have to be 10,000. So this is going to be 20,000. Okay. So y'all, one thing you could always do with your students, you could say, look, if the first number is going to be 20,000, that means that's the 10,000s, that's the thousands, that's the hundreds, that's the tens, that's the ones. My decimal point is going to come right here. Okay. So you can always kind of do this thing with your students to let them know, look, what's the first number I'm in? I'm in the 10,000s. So that first number is going to be at 20,000. And what's the rest of it going to be? I don't know. We're going to figure it out together. Well, if you notice, y'all, the next power that I have is a -2. That tells me that all the numbers here, y'all, have to be zeros, right? Because there's no other values that are given to me, so they all have to be zeros. Now, since that 9 is to the -2, that means that that 9 is two spaces to the right of the decimal point. And then the 5 has a 10 to the power -3. That means that that 5 is 3 spaces away from my decimal point. So what do I have to put here? Again, another 0, right? And again, this would be the approach and how I would show my students, right? So look, I would look at the first number and I'd say, look, that's 9 times 10 to the fourth. That's telling me that the first number I have is a 9 and it's in the 10,000s. So this is 90,000. Look, I'm going to go like this. 1, 2, 3. I'm going to put a decimal point here. I don't know what else is going to come along, but at least I know where I'm getting started from. Okay. So 90,000. The next number I see, y'all, is a 7 with a power of 10 to the -3. That means that that 7 is 3 spaces away from the decimal point, right? So then the only other alternative I have is to fill in zeros all the way across. Okay. Okay, and then I'm going to do the same thing for part D, y'all. Right? So if I was teaching 4th grade, right? Now I'd say, okay, look, y'all, let's see what we have. We have 10 to the -1, 10 to the -3, 10 to the -6. Okay, since I'm starting with 10 to the -1, I'm going to put a point here. I'm going to go 1, 2, 3. I don't know how many I'm going to need. That's right. We can put a 0 here in front of it because we know that there's no other numbers in front of that. So we know that that's going to be a 0. That's correct. Good. Now, y'all, I can always think about if there's no number in front of it, I can always pretend that it is a 1. So 1 space to the right of the decimal point, I'm going to have a 1. 3 spaces, 1, 2, 3 to the right of the decimal place, I'm going to have a 1. And 6 spaces, 4, 5, 6. Let me see. 10. That's 1, 2, 3, 4, 5, 6. That's going to be a 1. So then the rest of these, y'all, have to be zeros. Okay. And that's right. So if there's no other number in front, we would say, hey, y'all, the number in front is a 0. And I do remember this about elementary school, y'all. I might be 49, but I do remember this about elementary school. At least when I was in elementary school, my teachers were very adamant. Oh, come on, pen. That I put that 0 right there because they always said, hey, look, I don't know if those are decimal points that you put over here. Okay, look, there's my decimal point. Okay, well, write a 0 right there, Omar, so that we know that that's what you really mean. So, yeah, good point. Good idea to put that 0 there. Okay, let's take a look here at the next part, y'all. Let's see what we got. Okay, so again, y'all, when I'm thinking about how do I write our numbers, okay, and we're going to try to see if we can figure out how to write this kind of a number here. Remember, the most important thing, y'all, is that the and is always going to be where our decimal point goes, okay? And so when we're going to write these things out, okay, so it says 469. Okay, I know how to write 469, so I'm going to do it right here. 469. Okay, it says and 63 thousandths. So y'all, the way, again, I would show this to my class of fourth graders, I would say, look, this is the tenths, this is the hundreds, this is the thousandths. So this is tenths, hundreds. I'm writing real messy here, so I'm going to fix that. And this one here is thousandths, right? Okay, so look what we have. We have 63 thousandths. So if it's 63 thousandths, y'all, those last two digits or the last number has to appear in the thousandths position. So 63 has to go into the thousandths. So then what number has to go here? A 0, right? If I don't have a number to put in there, y'all, 0 is always going to be kind of like our filler, okay? And so again, what I'm really looking at here, y'all, is if I look to the right of my decimal point, the first one is the tenths, the hundreds, the thousands, the 10,000s, the 100,000s. If you notice at the end of each of them, they all have that little TH business, right? That just means that those numbers are to the right of the decimal point, okay? They're to the right of the decimal point, okay? So look, let's look at B. And it says 4 and 3 thousandths. Okay, 4, remember, and is a decimal point. 3 thousandths, so tenths, hundreds, thousandths. The 3 is going to go in the thousandths position. So then those have to be zeros, okay? Okay, y'all, when I look at part C, okay, and I'm just going to kind of get rid of that red line right there. Okay, I'm going to look at part C, and it says 469 millions. The first thing I notice, y'all, I don't see the word and. That just tells me that the number in front of my decimal point would be a 0. So look, I'm going to go like this, 0. Remember, tenths, hundreds, thousands, 10,000s, 100,000s. After 100,000s is millions, right? 469 millions. So 469, I'm in the millions position. So again, what has to go over here? We got to fill those in with zeros, right? Okay. And then finally, y'all, part D. Part D here says 5 million and, okay, look, there's the and. So let me write 5 million. So 5 million is going to go like this. Boom, there's 5 million, right? And, so, and 3 tenths. Remember, the first number is the tenths position. So the 3 is going to go right there, okay? Okay, so then when I look at the next problem here, right? And again, if I was teaching this to my students, right? If I had a group of fourth graders, and they were to say, sir, okay, look, how do I write 0.00037 in words? And I would say, okay, well, let's think about this for a minute. Here's my decimal point. Remember, tenths, hundreds, thousands, 10,000s, 100,000s. So I'm going to ask myself, 1, 2, 3, 4, 5. I got to have 1, 2, 3, 4, 5. There we go. So remember, this is tenths, right? This is hundreds. This is thousands, this is 10,000s, and this is 100,000s, right? So when I were to be looking at something like this, and I was trying to show this to my students, I'd say, look, we are in the 100,000s place value, right? Because we have 0, 0, 0, 3, and 7. So the way I would say this is I would say, well, how do I write that number? And hopefully, right, my group of fourth graders could say, well, sir, that's 37. Okay, and then we would say 3,700 thousandths, right? And that's how we would read that part. So again, y'all, when you're showing this to your students, and y'all, one thing I do want to mention before is, you know, this is a freshman level class, right? So if you want to become an elementary school teacher, obviously you need a 4-year degree. So, you know, you might get nervous in the sense and saying like, hey, look, you know, say 3 years from now or 4 years from now, if I'm graduating and I'm going to teach, am I going to remember everything I learned in this class? No, you may not. You may remember some of it. You may not remember any of it. You may remember all of it. you're going to have tons of training kind of opportunities and workshops and all that kind of stuff. And they're going to walk you through a lot of this process as well. But this is kind of the introduction to it, okay? Okay, so y'all, the next part here, we're going to talk about if a number, a fraction can be written as a terminating decimal. Okay, terminating decimal just means that if you were to divide it out, the decimal would end. Okay, it wouldn't be one of those decimals that goes on and on and on and on forever. Okay, and it says it can be written as a terminating decimal if and only if the prime factorization of the denominator contains no primes other than 2 or 5, meaning that if we were to break down the bottoms, the only numbers that we want to see in the bottom parts in the denominators is either powers of 2 or powers of 5 or combinations of 2s and 5. But we don't want to see any 3s, we don't want to see any 7s, we don't want 11s or 13s or anything like that in there. We just want 2s and 5s. So it says, I know it says mentally determine which of the following can be represented as a terminating decimal. Well, look at the bottom part. The bottom part is 5, right? I'm just looking at the denominator. I cannot break down 5 anymore. And 5, remember, the only numbers I want to have in my denominator, y'all, are 2 and 5. And all we have is 5. So I'm going to put a T. That means it's going to be terminating, okay? Now, I'm going to look at part B. I want you to look at my denominator. It's 20. Okay, what numbers do you know multiply to 20? Any two numbers, besides 1 and 20 though. What two numbers multiply to 20? 2 times 10, perfect. Oops, come on, pen. 2 times 10. Okay, can we break down 10? 2 times 5, right? Okay, so look, y'all, the only numbers that I see on the bottom are 2s and 5. That's all I want to look for. All I want are 2s and 5s. If I have anything besides 2s and 5s, it's not going to be terminating, okay? Look, let's do part C. Sorry, all my pen keeps freezing up here. Let's do part C. Okay, I see the number 12. What two numbers multiply to 12? 2 times 6. And we can break up 6 into 2 and 3. That's the problem right there, y'all. The only numbers that we want to have are 2s and 5s. Here we have a 3, so this is what I'm going to put. I'm going to put an NT. Why? It's not terminating, okay? Now, if I look at part D, y'all, my denominator is 2 to the 6. That just means it's 2 times 2 times 2 times 2, right? 6 times, right? The only number that I see here, y'all, is the number 2. So again, that's going to be terminating, right? When I look at part E, I see the number 14. I know we can break down 14 into 2 times 7. That's what's going to mess it up. It only needs to have 2s and 5s. So this here, y'all, is non-terminating. And then I'm going to do part F over here where I have a little bit more room. 625. I know I can divide it by 5, and that's going to be 125. I can divide that by 5, and that's 25. I can divide that by 5 and 5, okay? So the only numbers I see in my denominator, y'all, are powers of 5, either 5s or 2s. That's all I want. If I have any other numbers, it's going to mess it up. All we have are 5s. So again, that's going to be terminating, okay? That's what we're looking for. Again, when I break this down, y'all, the parts that if we have 2s and 5s, we're good. And it doesn't matter how many 2s or how many 5s we have. The problem is when we have numbers like 3s and 7s and 11s and 13s and things like that, okay? Okay, so for these problems here, it just says, when possible, write each of the following as a terminating decimal. Okay, y'all, this really here, this is really like a calculator problem. And I guess what the idea would be here is just to show your students, look, we want to see what are examples of terminating decimals, okay? And again, if you're in 4th grade or 5th grade, you know, I think students at that point are probably at least getting accustomed to calculators, right? And we're going to say, look, what's 3 divided by 5? Oh, look, that's 0.6, okay? Let's do part B, okay? What's 17 divided by 40? Look, it's 0.425, okay? Again, what do we mean by terminating decimals? Means that when I do this on my calculator, it doesn't go on forever, okay? I'll do the same thing here. I'll say, look, what's 4 divided by 8? Look, it's 0.5, right? Okay. And then we'll get to part D, and we'll say, what's 1 divided by 2 to the 4th? Okay, what's 1 divided by 2 to the 4th, y'all? Again, I would show this to my students. I would say, look, let's do it this way. 2 to the 4th means 2 times 2 times 2, right? And I would tell my students, okay, look, what's 2 times 2? And hopefully they'd say 4. And that's okay, well, what's 4 times 2? And hopefully they'd say 8, right? And I say, what's 8 times 2? And hopefully they'd say that's 16. So really what I'm doing here is I'm taking 1 and I'm dividing it by 16. Again, I get a terminating decimal, right? That decimal didn't go on forever. It's 0.0625, right? So 0.0625. And again, I'd probably put that 0 there, right? And then when I get to part E, I'd say, okay, look, what's 9 divided by 51? This is what we call a non-terminating decimal, right? Guys, it doesn't stop at the 41. It's just that that's all my calculator can do, right? My calculator can't do more than that part. So what would I do for this one right here? I would say, and these problems y'all are going to be like multiple choice. So you'd probably put something like not possible to write as or terminating decimal, right? Or you would leave it as 9/51, right? We just can't do it, okay? And then when I get to part F, I would do exactly the same thing, right? I would say, what's 119 divided by 15,625? And again, this is a terminating decimal, right? But it's 0.007616. Okay, but that's really all you're doing there, okay? Again, the big part of this, y'all, is how would you explain this to a group of 4th graders? Okay. Now, in looking at the next problem here, it says, in each of the following, order the decimals from greatest to least. Okay, so y'all, one thing that sometimes students have a difficult time understanding is what is greatest and what is least mean. So think about it this way, y'all. Most kids understand words. They understand big and small. What do you think greatest would be? Do you think greatest would be bigger or smaller? How would you explain that to a little kid? Say they're in 4th grade or 3rd grade. Is greatest bigger or smaller? Anyone know? What do you think? Greatest. Would it be bigger or smaller? Bigger, right? Okay, so look. This is big and that's small, right? Okay, so y'all, I'm going to look at the numbers that I have. I'm going to do part A, and I'm going to kind of do it like a really slow motion kind of way, because this, again, is how I would show my students. So let me get rid of that. I don't need it. Okay, so the first number is 23.78282. The second number in the list is 23.78295. Okay. The next number in the list is 23.783. And the fourth number in the list is 23.7829. Okay. So remember what we're going to do. We're going to put them from biggest to smallest. Okay. So the first thing we would do is we could say, well, look, all the numbers are 2s. So far, nothing is bigger. All the numbers are 3. So far, nothing is bigger. Same thing with the 7s, they're all the same. Same thing with the 8s, they're all the same. Okay, now we're talking. When I start to look at this column right here, this number is bigger than all the other ones because all the other ones are 2s, and that's a 3. So the biggest number I would have, and I would put this like this, 23.783, okay? That's the first number, okay? And that's going to be bigger than. Now I want to do a little stare and compare. What's the next biggest number? So look, we already got this one here, y'all. Now, okay, well, I know that these two numbers are going to have to come. One of those is going to have to come next, right? Now I've got to figure out which one is bigger. Y'all, if there's no number after this 9, it's a 0. So what's bigger, 5 or 0? Hey, 5 is, right? So then right here, y'all, I would put 23.78295, okay? And then this would be the next one, 70 or 23.7829. And then the last one would be the first one that was in our list, 23.78282. Okay. And y'all, the reason I'm running it this way is in your homework, they have these little bigger signs, little greater than signs. And so this is the biggest, this is the next one, the next one, the next one, the next one, okay? Now, y'all, for the next part here, for this part here, y'all, you would probably start seeing negative numbers in maybe say in 5th grade, okay? Maybe even in 4th grade, but definitely 5th grade you'd see it, okay? So again, the way I would approach this with my students is I would say, look, I'm going to look at the numbers that I have, and y'all, I'm going to erase this part because we already used it. And I need some room here. Okay. So for part B, okay, this is how I would write my numbers. Negative 8.698, negative 8.62, negative 8.6028, and negative 8.628. Okay. So y'all, again, if I'm dealing with a group, say of 5th graders, the one thing I would definitely remind my 5th graders of, and I'm going to do this over here on the side, is when I draw a number line, okay, so here's my number line, okay, and I start to do this like 0 and 1 and 2 and 3 and 4 and 5. And on this side, again, right, this is how you would show your 5th graders, right, or maybe even 4th graders, is you'd say, look, numbers that are further to the right, oh, come on, pen. Numbers to the right are bigger. Numbers to the left are smaller, okay? So you might say something like, and they might ask you like, Miss or Sir, what do you mean by that, okay? And I would say, look, let's pick 2 numbers. Let's pick -5 and let's pick -1. And if we want to know which number is bigger, numbers to the right are bigger. So -1, y'all, come on, pen. -1 is actually bigger than -5. Why? Because it's further to the right. Or numbers that are to the left are actually smaller, okay? So if -1 is bigger than 5, that means that -5 is smaller than 1. So as I start to move to the left, these numbers over here, y'all, are actually smaller, okay? Are actually smaller. So when I would come back over here and I would look at my problem and I'd say, okay, remember, I'm going to do this from the biggest to the smallest. Okay, because my numbers are negative, I'm going to say, look, well, those numbers are all 8s, so we're good. And we have all 6s, so we're good. This is actually going to be my biggest number because it's a 6.0. And that number is actually going to be further to the right than these would be, right? That number would actually be further to the right. Because again, if I think about it, remember, these numbers are actually bigger than those over there, right? So the closer I am to 0, the bigger my number is, okay? And when you deal with negative numbers at first, you know, kids kind of get a little confused with it, right? But I would say, look, the biggest number I have is -6.028. And that's going to be bigger than, okay, so we got rid of this one. I want to look, okay, what's the next biggest number? Well, remember, this number right here, y'all, is a 0. This number is going to be bigger than that one. -8.620, okay? Then that's going to be my next one, -8.628. And then my last one would be this one here, -8.698. Okay. And again, that's how I would show this to my group of 4th graders or 5th graders or whatever it happens to be, right? Okay. But again, I would demonstrate this kind of stuff on the number line. Like I said, we're visual learners, and looking at the number line makes it easier for me to understand that idea, okay? Okay. So the directions for the next problem here to say, write the numbers in each of the following sentences as decimals and symbols, okay? So all they're asking me to do, y'all, is how would I write the number in as a decimal? Okay, it says an insect has a body length of about 14 hundredths of an inch. First thing I notice, y'all, I don't see the word and. So there, the number in front of my decimal point, y'all, is going to be a 0. Now remember, the first number is the tenths. The second number is the hundredths, right? And I'm going to stop there, y'all, because we're talking about 14 hundredths of an inch. So for part A, how would I write this? 0.14, okay? And again, y'all, I'm thinking that, I've never taught elementary school, right? But I'm thinking that this is how I would show my students. I would write those numbers to let them know those are the place values, right? And the more often, think about it, when you're learning something for the first time, it's always really tough. So the first time you're showing this to your students, you tell them, look, we're going to keep doing this a little bit. And then after maybe a few days, maybe even a week, do I still have to write it? Well, if you remember, you don't have to write it. But if you forget, then write it down, right? Okay. Now, part B says a planet goes around the sun once every 424 and 59 thousandths days. Okay, I see the word and. So this number right here, y'all, is telling me the whole number part. So 424 point. Okay, 59 ten thousandths days. Okay, so look, I would go like this. That's tenths, that's hundredths, that's thousandths, and we want 10 thousandths, right? Okay, 59 ten thousandths days. So 59, the 9 has to end up in the 10 thousandths. So what numbers am I going to put there? Zeros, right? Those are like my placeholders, right? Something has to be there, okay? Okay. All right, so look, y'all, it says if the decimals 0.08, point or 0.0, I can't even read it, 0.805, 0.85, and 0.844 or 8422 are arranged on a typical horizontal number line, which number is furthest to the left? Okay, so I want to think about that, what they're asking me to do. Here's a number line, okay? We're going to put these numbers furthest to the left. We're going to put these numbers from smallest to biggest. Again, if it helps y'all, do this, 0.8422, 0.85, 0.805, okay? So again, what I would show my students, I say, look, those numbers are the same. I'm looking for the smallest number. So in the next part, what's smaller, 4, 5, or 0? 0 is, right? 0.805, right? And then the next one would really be 0.8422, and the last one would be 0.85. They really just wanted to know which was the one to the left, so that would be the one to the left, right? That's really the smallest number, okay? Okay, so the next part here, y'all, says write a decimal that has a non-zero hundred thousandths place and is between 7.35 and 7.351. Okay, so again, this is what I would do. I'd go like this, 7.35. Remember, that's tenths, and that's hundredths, right? And we want 7.35 or 7.351, okay? Again, this is tenths, that's hundredths, that's thousandths. We want something in the hundred thousandths place, okay? So, and we want a number between those two. So 7 point, and I'll write it a little bit with a little bit more space in here. 7.35, okay. That's tenths, that's hundredths. The next one, y'all, would be thousandths. The one after that would be 10 thousandths, and we want 100 thousandths, okay? Okay, so what I'm looking for, y'all, is a number that's gonna look like this. and I want something right here, okay? Remember, tenths, hundredths, thousands, 10,000s, 100,000s, okay? So I'm looking for 7.35, right? And then something here, and I need to fill in a value there, okay? So look, I'm gonna do a little stare and compare. So let's take a look. How many decimal places to the right do I have? 1, 2, 3, 4, 5. Okay, so if I come back over here, I want to see which ones have 5 numbers to the right of the decimal place. Well, not that one, and not that one. So I got a couple of choices. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so it's either going to be choice B or choice C, right? Now, y'all, it needs to be between, oops, sorry, that's not what I wanted to do. It needs to be between those two numbers. So remember, think about it this way. The number here is a 0, okay? The number here is a 0. And we want it to be between those two numbers, okay? So one way I could do this, y'all, is if I look at the number that I have, 7.351, I could put zeros like that, right? And that's really the same number, okay? And this one over here, I could put zeros like that, and that's really the same number. So which one of the numbers here between B and C is between those two? If I look at B, isn't B actually bigger than that one there? Because this one ends in a 0 and that one ends in a 3. So the choice that I have to pick, y'all, is going to be choice C, right? Because that's the one that's going to be between those two numbers there. Okay, it'll be somewhere in the middle. Maybe not exactly in the middle, but somewhere between them. Okay. Here's my next problem. It says the 5 top swimmers in an event had the following times. Okay, in order of how they placed, they were, so let's think about this, y'all. We're at a swim meet. Who gets first place? The person with the shortest time or the person with the longest time? What do y'all think? Anyone know? Who would be first place? The shortest time or the longest time? The shortest time, right? Okay, so look, we're gonna do a little stare and compare. Let's take a look and let's put them in order from fastest to slowest. Do you guys agree that Rhonda would be in first place and then Molly in second? Who would come in third? Kathy, Emily, or Martha? So these are first two, right? Now I want to do a little stare and compare. Wouldn't Kathy be third? Wouldn't Martha be fourth? And wouldn't Emily be fifth? Right? So again, y'all, I'm going to look, okay, Rhonda, Molly, Kathy, Martha, and Emily. Okay, Rhonda, Molly. So it looks like choices 1 and 2 are Rhonda, Molly, Kathy. Okay, so choice B, right? Wait. Oh, you know what? It was the opposite, right? I looked at the wrong number. Martha's actually in last place, isn't she? Oops. Emily and then Martha, right? Because she's 63. There we go. So there's choice B. Okay. Now, I believe this is the last question y'all hear out of 7. Last question out of 7.1. It says, suppose a carpenter's ruler was marked in 32 seconds. What would be the fraction and its decimal equivalent for the mark on the ruler between 9:30 seconds and 10:30 seconds? Okay, so y'all, the way I would do this, we're looking for what's the number in the middle here. If we're looking for the number in the middle, what we're going to do is we're going to add those two fractions together and we're going to divide it by 2. So remember, y'all, when we are adding fractions, right, we just add the numbers on top. That's 19 over 32. Now, we're going to divide this number by 2. But again, we've talked about this before, right? And again, this is what I would show my students. I would say, look, y'all, remember what it means to divide? It means to multiply by the reciprocal. So this would be 19 over 64. So the fraction here, y'all, would be 19 over 64. And then the second part is, well, what's the decimal? Well, let's take our calculator and what's 19 divided by 64? And I'm coming up with 0.296875. 0.296875, okay? Because we add the two numbers together and then we divide it by 2. And the same thing, the way we divide by 2 is we multiply by the reciprocal, which is 1/2, right? All right, so y'all, that's 7.1. Let me go ahead and stop recording. Like I said, y'all, 7.1 is not due until Monday the 21st, okay?